oh my gosh, you can work on Cheetos for a living? And they were explaining some of the technical challenges behind food. And I thought, this is the most fascinating thing I've ever heard.
Who are the people behind the scenes making your favorite soda? What inspires someone to make the snacks you enjoy with friends? Today on Origins with Dr. Natasha Wilson, our guest, Dr. Renee Hale, a chemical engineer working at PepsiCo, will share how she developed a passion for producing the foods we know and enjoy. We'll learn about her childhood and early career, which have led her to where she is today, here on Origins. Well, welcome, Dr. Hale, to Origins. As we start off, we like to begin in childhood. Perhaps you can start by telling us a bit about your childhood.
Sure. Well, I grew up in upstate New York, and then later in life moved to the Oklahoma and Texas area. I grew up in a family that was full of people with engineering tendencies. So my dad is an engineer, and all of my siblings ended up being engineers too. So we were quite the household full of tools and tinkering. And so I grew up around a lot of STEM-focused activities.
Because you were growing up around people who are interested in STEM, were you automatically drawn to it, or did it take some time for you to build the interest?
Yeah, I actually didn't want to be an engineer because everyone else in my family tend towards mechanical engineering, which is a lot about building things, designing hardware, tools, and I wasn't really drawn to any of that. And I thought that all engineers drove backhoes because my dad likes to work with heavy equipment. So I thought, well, I don't really want to drive a backhoe, so I guess engineer is not the thing. But it wasn't until I started looking for universities that my dad said, well, there are more branches of engineering than just the one. And I said, no, you didn't tell me that. So we kind of happened on it accidentally. And so I looked at the options and thought chemical engineering looked interesting because of the medical applications to it. So that's what brought me in. As I went through the program, I realized that wasn't as much of an interest. So I pivoted away from that. But growing up, I did a lot of music and dance. And so I was thinking way more in that direction than I was any sort of science-focused career, to be honest. I was homeschooled growing up, more so because of the academic flexibility. My siblings and I were ahead of the curve as we were really young. So my parents chose to see how homeschooling would work, and it worked really well for us. So all of my subjects were fairly challenging because they kept me kind of at the limit of what I knew all the time. So
how do you think that your homeschooling impacted your career? It sounds like your classes were a bit more challenging and you were, like you said, pushed to the limits. Maybe you were also given a little bit more freedom to explore things that you're interested in. Maybe you could speak a little bit about that because maybe a lot of people don't have a lot of experience with homeschooling and knowing how that works.
Yeah, and it works differently in a lot of different places. The way it worked for me was that it taught me to be very self-motivated for learning. I was given a lot of flexibility to pursue areas of interest. We had our core subjects, but then we went to the library a lot, and I love to read. And so I picked up books of all sorts. So very early on, I had, and still today, I have a really high curiosity about things. I love to learn, and I love to learn broadly. So homeschooling was a really good way for me to have that freedom to do that. Not to say you can't have that freedom in other places as well, but that was something that was highly encouraged, was independent learning and just following where your curiosity takes you. And that has served me well throughout my life, and especially in my career, because there are many, many things to learn in this world. And I've enjoyed getting to explore even as I grow.
So you mentioned that your family was very STEM focused, engineering focused. Is that true of your siblings? How many siblings do you have?
Yeah, I have an older sister and two younger brothers, and they are all mechanical engineers doing various things with their careers. So, and my sister married an engineer, and I also married an engineer. So we are pretty well inundated. My mom homeschooled us and then became a professional photographer later in life. And so she just really tries to hold down the non-engineering side of the conversations. And she does a great job at it.
Yeah, that's really interesting. And What is it like with your siblings? They're all in mechanical engineering and you're in chemical engineering. So I guess when you get together and you're kind of sharing about what you do, what is that like?
It's a lot of fun, honestly. We have really, really dorky conversations that I really enjoy. Mechanical and chemical engineering do tend to have a lot of overlap in the foundational understanding of what we're taught, and in a lot of the applications that we work in. It could be done by either mechanical or chemical. So we often find a lot in common to talk about. And I really enjoy hearing about what my siblings are working on and then sharing what I am. And so I learn a lot from them. And occasionally they'll come to me for advice. And so it's been fun to have a commonality there that we can encourage each other in our careers and give advice, and sympathize when things are going wrong in a way that's in a way that other people couldn't, that are not in the engineering field. So that's been a real positive.
That sounds great. And it must be encouraging and very supportive environment to have your siblings and your spouse all in the same field, and have those opportunities to grow together. So that's great.
Yeah.
As you were moving through school and graduating high school, how did you think about, you mentioned it a little bit, but how did you think about your next steps moving into college?
I was looking primarily at universities in Oklahoma because that's where we have some extended family. I remember looking at a couple of different universities. We took the typical university whirlwind tour where you go to each one of them and talk. I was looking personally for schools that had good music and dance programs, because I knew that even if I didn't major in that, which I knew I wasn't going to solely major in music or dance, I did want a university that had some sort of program I could get involved in and keep those skills up. And then at the time I was thinking business as a degree. My mom did a business degree and it's a good solid degree. So here we are. Oklahoma State is where I ended up, and we kept it on the list because it's my family's alma mater, and they said you should at least go look at it. And so it was during that visit that my dad pulled some connections to the engineering department where he went, and they kind of recruited me into the program and said, "So have you considered engineering?" And I said, "No, because I don't want to do engineering." And they said, "Why not?" And I said, "Because you can only do tools." And they're like, "Oh, that's not true." So I was recruited into engineering over lunch with the dean. And yeah, that's how I ended up in engineering. It was a surprise to me to end up there. And I still am kind of surprised that I'm here, but I really am glad that they took the time to try to show me that there were more options than I knew in life, and give me some new opportunities.
So engineering can be an overwhelming discipline when you first start, especially the first couple of years. At least that was my experience, I think, as a chemical engineer. Lots of classes, lots of very tough classes. It seems as though you're taking classes from almost every hard science discipline in the beginning. And so as someone who wasn't necessarily planning to take that on, what was it like for you?
I guess I really didn't think about it much. I just kind of signed up for what I was supposed to sign up for. And I think I had a natural aptitude. I was good at math and science. I didn't know that I was. I just did chemical engineering. It's a good option. Here's the classes, start the classes. And as long as I don't completely fail at the classes, I guess I'm good. I don't remember enjoying the classes, but I don't remember hating them either, if it makes sense. I really didn't know. I didn't really know what I was going to do with the degree. And so it was hard to envision, oh, I'm taking these classes because I can totally see where they're going to go. I just kind of took the classes, and I think I found them interesting enough to enjoy it. I enjoy understanding how the world works. I think that's what's really satisfying to me. And that comes in so many different ways. So biology was fascinating because the photosynthesis cycle, I'm like, this is amazing how this works. And then you get to chemistry and you understand how the molecular bonds work. And I'm like, this is amazing how this works. So everything was just like, this is fascinating. And you just move on. I do remember there were classes I didn't particularly gravitate towards. Physics was one of those. I never quite figured out physics. So I just kind of made it through those, but there wasn't any one particular class that popped significantly more. So I just kind of went through and figured I'd find something.
Did you still end up being able to do music and dance while you were pursuing your chemical engineering degree?
Yeah, I didn't end up doing dance, but I did continue music. So I grew up playing violin and piano. And so throughout Oklahoma State, at least, I took piano and violin lessons from the professors there. You could, if you were a non-music major, you could still sign up for, 1 credit hour, and they would teach you, which was fun. And I played in the symphony on and off as I had time to. After Oklahoma State, those skills, I didn't have as good of an outlet for that. So I haven't done as much of it now. But yeah, throughout my undergraduate, I was able to keep it up.
Where did you go from college?
Okay. So I went to Oklahoma State for undergraduate, finished that chemical engineering. I had a scholarship that supported me through undergraduate, but also included a year of master's study at the University of Cambridge in England. And so the premise was, if you can get into Cambridge, we will fund your master's program. And so I was successful at that. So I went, their programs in England are shorter than they are in the US. So it was just a 1-year program, but that was a lot of fun. And I picked chemical engineering again. I don't know why I didn't think to look for more options, because they have such fascinating, I've looked at them now after the fact, and I was like, oh my gosh, I could have done all these different things. Why did I? Anyway, so did chemical engineering, but it was a good program because it wasn't just chemical engineering. They also had some business classes, some entrepreneurship classes. So I really got a wide diversity of things. And I continued my music through that as well. Some of the colleges at Cambridge have choirs that sing weekly, and I have a decent singing voice. So I got to jump on one of the college. I sang for Sydney Sussex College choir, which was a lot of fun. And we did performances every week, and then we did some tours and things. So that was I had to learn how to sing in Latin, which took a while. I mouthed a lot of words before I actually sang them because I didn't know how to pronounce Latin, but I caught on. And then after that, I knew I wanted to do a PhD because I had interned at ConocoPhillips in their R&D center between Oklahoma State and Cambridge. And that is when I figured out that research was what I wanted to do as a career. They had a big research center, and I was working in their carbon dioxide capture group, looking at different materials for amine scrubbers. But I got to visit people who worked in algae biofuels, and there was a group that worked on methane hydrates, and there was a group that worked on, something else. And I thought, oh my gosh, I could spend my whole career here and never get bored. Because if I get bored with my group, I just go to a different group and they're doing something completely different. And I thought, this is phenomenal. So I said, what do I need to do to come back and work at a place like this? And they said, well, you probably need your PhD. Right. Go get to PhD. So I had visited Austin when I was at Oklahoma State. I really loved the city and the town. And so I thought I would love to live in Austin for some period of time. And UT Austin happens to be a really highly ranked graduate engineering program school. And so it all kind of came together. Nobody told me you were supposed to apply for multiple graduate schools. I just did the one. I don't know why nobody told me that, but I was like, it's either this one or it's nothing, because there's nowhere else I really want to go. So it's not recommended apparently, but it's fine. So it worked out. And so I did my PhD at UT Austin. I got my degree in chemical engineering. I never worked for a chemie professor. I actually worked for 2 different mechanical engineering professors because they were doing more interesting work to me personally than the chemie department. So I had this crossover thing happening, and my first professor didn't get tenure and left. And so then I had to do a different professor. Also not recommended, but it worked. And then PepsiCo came down and recruited. A couple years before I graduated, they held an info session. And honestly, the only reason I went is because it was in the morning and I knew they would have bagels and coffee, and I just really wanted some free bagels and coffee. So I figured might as well, I could sit here for an hour for bagels. But it ended up being really fascinating. And I thought, oh my gosh, you can work on Cheetos for a living? And they were explaining some of the technical challenges behind food. And I thought, this is the most fascinating thing I've ever heard. So they also described a company culture that seemed healthy, open, collaborative, welcoming. And so I thought I'd give it a shot. And that's how I ended up here. But yeah, it's just coffees and bagels was honestly the only reason that I discovered the food industry. But here we are.
Well, speaking of the food industry, can you tell us a little bit more about what chemical engineering has to do with food?
Yeah, so I was thinking about how to describe chemical engineering in general and then how it applies to food. So usually when people say, well, what do chemical engineers do? I describe it as taking something that you can do in a small amount, like on your kitchen counter or in a chemistry lab somewhere or in your garage, and figuring out how to do it at bigger scales so that you can create more of it at once. So that's called scaling up in industry speak. But as it applies to food, food is chemistry too. It just happens to be chemistry that you can eat at the same time. And so a lot of the transformations, the chemical reactions, those are all really similar to what you learn in school. And it makes sense once you think about it. Just no one had ever explained it. So a lot of what I do and what food engineering is about is taking a food product that you could make in your kitchen and figuring out how to make it at vast quantities so that you can supply it to many, many people.
So you're on the research side, correct?
Yes.
So what kind of research do you do?
Okay. So I do two main types of research. One is developing new food products for the market or improving the products that are out there. So we do a lot of experimentation with different ingredients, different shapes, different colors, textures, to figure out what the best combination is to put something new out there that people have never seen or to make something that's already out there better. So I do a lot of experiments where we're running through all of the different variables and factors and seeing how it affects the end product and then picking the best combination of them. The other type of project I do is figuring out how to optimize the process itself. So maybe the product I'm making is the same and I don't want to change that, but maybe there's ways to make the equipment more efficient or help things be more precise. Or a lot of what we do is try to take the load off of the people who are running the equipment so that they don't have to make as many decisions at once and it reduces their cognitive load on them so that they can run things more smoothly. So I do a lot of research on that too.
I think most of us think about food kind of, we may use our parents' recipe or something like that to make something. And now you're saying, well, I do this in the lab. So is there a way to think about just where do you start there? I mean, does it start in someone's kitchen and then end up in the lab? So in terms of thinking about how to create this new product, like what is the thought process that goes into that?
Yeah. No, generally in the new product development cycle, and this can be broadened outside of food to really any consumer goods that you're creating. When you create something new, you first want to ground it in the people, be human-centered and say, we are all people. And so I'm making this product for someone to enjoy. So who is that person? What do they need in their lives that I can help fulfill for them? And you ground it in the needs of the person. And so we have some groups that help us do consumer insight work. So we go out and ask people and say, hey, what do you feel like you don't have a good product for today? And what would you love to see? And then we take that back in and we use that to craft, to do a design and say, if I were to create something that helps people, for example, I get hungry in the morning right around 10:30. I don't eat breakfast. And so I drink my coffee and at 10:30 every morning, I'm like, got to have something before lunch. And so I have my set of, granola bars and things that I like to go eat, but that's something I need. And I am not always particularly happy with what I have to choose from for that. So I have some ideas about like what I would rather eat at 10:30 than what's currently available. So you start there and then you start asking questions and say, well, what kind of things would you want in that product? And then you also think, what ingredients do I have available to me? What do I have in my pantry that I can use? And you kind of marry those two together. And then we usually prototype or make small amounts. Either sometimes it is in an actual kitchen. Sometimes it's using small versions of our equipment that we use at a large scale. We make a variety of prototypes, samples, and then we show them back to consumers and say, hey, does this fit what you were thinking? Do you like it? and they give us feedback and we iterate from there. And then eventually you find something that both people say, this is amazing. I would buy this if it's exactly my 10:30 in the morning hunger cravings. And then you're like, great, we have hit our target. And then my job kind of ramps up where I'm like, okay, once again, I've made a few of them. Now I need to make a bunch of them. How do I go do that in the best way? Does that answer? Does that help?
It does. Yeah, it does. Definitely. Then when you're trying to make it bigger, someone might think, okay, you just use a bigger pot or you just use these. So how do you think about making food for millions of people?
Yeah, sometimes you do just use a bigger pot, to be honest. There are, especially when you're cooking things, like if I cook something on my stove, it's in like a pot. There are companies that make massive pots. They're called kettles, and you can cook a bunch of stuff in there. You have to think about if the time is going to be the same, if the temperature is going to be the same, because the way the heat moves around a big pot is different than how it moves around a small pot. So those are the things that chemical engineers are trained to think about and figure out how to scale. I have been really surprised at how much creative equipment there is in the food industry. And so I've Googled a lot of, and a lot of how it's made videos are helpful to learn about things. So there are, for example, when people will make pasta, sometimes they'll squeeze it between two rollers and you get this really thin sheet of pasta, and then they have to squeeze it multiple times and they cut the thing. There are massive rollers that you can use to squeeze the pasta, and I didn't even know such things existed. And so you go buy some of those, and then they're like, well, what kind of surface do you want on your rollers? And I was like, I didn't even know we had options. What are my options, and what do they do? And so a lot of times it is really similar to what you have in the kitchen. It's just bigger or slightly different. There are some technologies that are very difficult to do on the kitchen scale, but that you can do it at high volume. But those are less common to find.
So what are some of the challenges in scaling up such processes? I imagine that some of those challenges may be kind of the physical constraints of what you're working with.
Yeah, one of the biggest challenges that I didn't think about until I got into the industry is how much variability you have in the ingredients inherently that you have to work with. It's very difficult to make the same quality of food and the same outcome when the ingredients you're using to make it change on you. That's every engineer's nightmare, is to have an uncontrollable input to your process. Yeah. But a lot of food is, because it's grown and it's made in the world, there are seasonal variations. There are, depending on how much rain a crop has gotten or fertilizer a crop has gotten, you have differing things coming into your manufacturing line. So that is one of the biggest challenges, is figuring out how to make the outcome of your process, the food that you're making, the same quality, the same characteristics every time, even when what you have coming in tends to change. Sometimes you have wheat that has a little bit more protein in it this year, and last year it didn't have quite as much, or maybe it's a little bit wetter because of the conditions in the place it was grown. And so all of your process has to be able to react to that in a way that still creates the same outcome. And that can be a big challenge, but it's a fun challenge to try to deal with as an engineer.
Have you ever sensed any synergy, I guess, between your music and dance talents and chemical engineering, even if it's just maybe in like how you think about problems or how you think about the world?
It was funny that you asked this, because it's only been in the last year or two that I've really started to pay attention to how it might show up. And I think in my life, it shows up in two ways, at least in engineering. One is that I am super fascinated by how people use what they hear and what they feel to operate equipment. And so when I'm in a manufacturing plant for work, I will pick up on how equipment sounds and how it feels to be around it. And often you can learn a lot about how things are working by paying attention to what comes into your senses. So it's a lot of, like, music and dance is a lot about paying attention to what you hear and how rhythm works and responding to things. And it's a lot like you drive your car, when your car sounds funny, and you're like, something's not right. I don't know what it is, but it's not right. And you can do the same thing in so many different ways, and people do it all the time. And I'm just fascinated by that. And I think that partly comes from my attunement to music early in life, that I hear things and I sense things in ways that maybe other people don't pay attention to. The other thing is that it's really satisfying to play in a band or a symphony and orchestra and have lots of things coordinated precisely. It's so satisfying when that happens, when everything comes together. And so as an engineer, I really love optimizing systems and making them run together really efficiently. And so when things are out of sync and you can bring them all into sync and it's running like it's supposed to, it is one of the best feelings in the world, I think. So there's some similarities there between performing music and everybody working together and having a system that just like comes together and operates really well.
Those are really great reflections. I used to work in a manufacturing plant as well, and I can't necessarily say that I had that great attunement, but that really sounds like a kind of a gift from your music background to have that attunement to the vibrations, like the frequency of the vibrations of different equipment in the plant. So I never thought about that, but that's a really good reflection.
Yeah, and it's not like I have super sensitivity, but I do pay attention to it. It occurs to me more than it occurs to other people. I think I was in a manufacturing plant one time, and we were installing a new piece of equipment, and we were trying to figure out how fast it was cycling. It had these blades that were moving up and down, and my coworker was trying to time it by visually watching these things and counting how many times they moved up and down within a minute. And it was so fast, he was losing track count in his head, and he was staring at this machine trying to figure it out. And I said, but you can hear it. I said, it makes noise every time it moves up and down. It was a rhythm. And so I just stood there and I counted the rhythm, 5, 6, 7, 8, 9, 10. And I had a more accurate count than he did, because it's a lot easier to listen to a rhythm than it is to try to catch it with your eyes, depending on how fast it was moving. So I couldn't believe he wasn't going to use the sound. Maybe he's just being stubborn. I don't know.
Yeah, but it's such an interesting insight because you have that experience. You know what I mean? You have the experience of listening to a rhythm and, kind of basing your actions and your flow or what have you off of that rhythm that just somebody else may not think of until you bring it up. And so that's just a really interesting insight. And then also about optimizing, that definitely is a good feeling in your optimizing processes. It's such a great feeling when you get something just going, so that's great. What successes have you experienced in your work so far? And then what challenges do you generally face?
Yeah, success is an interesting thing to define. You might think success would be putting a new product out on a shelf that people can buy. I honestly don't quantify success that way, because sometimes products go away. You might launch something and it stays for a couple of years. It might stay for a while, but eventually the product usually gets pulled from the shelf. And then you think, well, if that was my success, what do I see for it? So I've learned not to quantify success in that way. For me personally, I consider success to be moving collective knowledge forward and getting to do work that I find fun. So as long as the work I'm doing is high quality and it teaches us something that we didn't know before, that helps us make good decisions or helps us accomplish whatever we're trying at this particular moment in time to accomplish, then to me, that's success. I honestly, because I'm a researcher at heart, I love knowledge for the sake of knowledge. So even if I'm doing an experiment and it doesn't come out like you think, you're like, well, that's still fantastic. We look at that. Something we didn't expect. What does that teach me about the world, and where do I want to go from here? So nothing is ever really a failure. It's always just something you didn't know before.
This is a question from Dr. Shenell Tolson. So she asks, if you are not employed in your current field, what would you be doing?
Oh, gosh. Well, when I was 8, I wanted to be a river dance person and be on an Irish step dancer and be on the river dance tour. So that's like if I had a second life. But more seriously, if I was not in food R&D and I was still in engineering, I would be more in the teaching space. The instructional design space, I think, is really interesting. If I was not in engineering at all, then probably something related to journalism, particularly anything that has me in front of a camera. I really enjoy This is music and dance. There's a performing aspect to me that I really enjoy, being in the spotlight. And so I've thought about like the How It's Made show would be really fun to be a host of and get to go and see all these different things. But, America's Test Kitchen is really interesting. They have people who are in front of cameras, but then they talk about the food. So all of those are still tangents of what I currently do. But if I was not in my current field, I would probably gravitate towards something with a performing and a teaching aspect to it.
Yeah. Oh, that's great. What is something that you wish that that others understood about what you do?
Oh, we talked about this a little bit about manufacturing at large scale. I wish that that more people understood, or I could somehow communicate and teach that just because something is made on a large scale doesn't mean that it has any less quality or care or passion or attention to detail put in by the people who are making it and designing it. I think many times in media, I will read about big X, like big pharma or big oil or big whatever the thing is, and it's often in a negative light. Mm-hmm. And just because something is big doesn't inherently make it any more bad or wrong or less curated. There's so many assumptions that go into equating large scale with a whole list of characteristics that I have not experienced to be true in my interactions with working for a large scale company. So I wish that more people knew that about large scale manufacturing.
That's a very good point. That is a very good point, because I think that those terms do get used very easily in the media and in conversation, and not really recognizing that there are people like you who really do care about the end user and start with the person who's going to be, enjoying that food and want to see them enjoy something at a high quality. It's just kind of this big impersonal industry that's happening and doing things behind the scene and assuming something sinister for that matter. So
yeah. So if I've been toying with this idea in my mind, and I may end up later in my career putting together some thoughts around it, but I think it'd be really interesting to explore what inherent assumptions we as a society have about things made at a small scale versus things made at a big scale, and exploring the tensions between those two. Mm-hmm. And I think a lot of people we interact with small scale all the time. We go to a coffee shop, we see a barista, they're making a coffee. We know what that looks like. We know what that feels. Heck, I have my own espresso machine. I can make my own coffee. So it's so familiar to us because we see it, but normal people don't, like the vast majority of people don't get to go inside of, Folger's coffee roasting plant and see what that looks like, or something on a massive scale. You don't see it, and so you don't know what it's like. And right. I think it'd be really interesting to do. This is one of my passion projects. Is I would love to do a How It's Made for food, but not just how it's made at big scale, but take something at kitchen and then show how it translates to small scale, like making cranberry sauce in your kitchen. How do you do that? How does Ocean Spray do their cranberry sauce, and what's similar and what's not similar? Because, it's just a pot. It's just big. It's still a pot. It doesn't need to be as mysterious and, like you said, just unknown as I think it is today.
Yeah. And I think it's just important to, even for those who are going into engineering, because I know when I was doing my heat mass transfer class, for example, I always complained that I don't know what a pump looks like, and you're expecting me to do calculations around a pump. I don't know what so I was like, it would be great if we could go visit a plant so I can see what these things are, what they're doing, how they're connected. So even just from that perspective, just helping those of us who need a little bit more hands-on experience as we learn. What's something that you learned recently or later in life that you wish that you knew earlier?
Oh, this is a good question. I had to think about this one this morning for a little bit before I came up with what I wanted. I've learned a lot of things I couldn't think of, but what would I have rather known earlier? Because a lot of things you just learn, and you're like, this wouldn't have helped me earlier. So it's fine that I didn't know it then. But I think one of the things that I wish I knew earlier was that there will be growth and learning opportunities in life without me having to orchestrate every single one of them. I think when I was younger, you're in school, you go to class, you read your textbooks. That's how you learn and grow. It's all, you have to go do the thing. And in college, if you don't sign up for the classes, you're not learning what's in the classes. So I guess I expected, and it's also kind of taught to you, you have to go out and get an internship and take these classes and read these books and grow yourself. And so I came up with the idea subconsciously that any way that I'm going to grow is because I have orchestrated it for myself. And therefore, if I don't orchestrate things, I won't grow. What I've learned now is that in my career, I've been given projects that I didn't have to come up with. And they've grown me in a lot of different ways. Just by virtue of being in the company, you're going to come across things and work on things. And you don't have to have figured it all out. I've also had a lot of life circumstances come to me, whether or not I wanted them. Like, we own a house now and my grass is dying in the backyard because Texas is hot. And so now I'm learning how to work with the landscaping company. And so there we go. I didn't have to think, I should learn how to do landscaping. Let me figure out how to, but now I know kind of how to do that. Not all of them are pleasant growing experiences, but I think there weren't things that I could have anticipated. And I don't always have to work to set up opportunities for myself all the time. It's not to say you do nothing, but I think I wish I knew that to relax a bit more and to know that I can set some things up, but that there will be opportunities for me to learn and grow that I don't have to necessarily go out and work for.
Yes, that's definitely true about life and about work, is that there will be plenty of opportunities to grow, be pushed to your limits and think, I'm not sure in this moment if I can get past this thing. And then you realize you can get past this, this challenge. You're doing an experiment and maybe it keeps failing and you're thinking, gosh, am I ever is this always going to fail? Is this just a failure? And then you have that kind of eureka moment, or just being able to learn things like resilience and perseverance, and then those collaborative skills as well, come out of things that you don't orchestrate.
Yeah, the quality of people that you work with, especially during a career, are really important because they will make the difference between something being a crisis and completely going off the rails and something being a challenge you can overcome together. I have learned, this is not something I wish I knew earlier, because there's really no way I could have learned earlier or needed to know it earlier, but there's very rarely a catastrophe in work unless you're working with something really, there are some careers where things are catastrophes, but very rarely is something, at least in my line of work. And there's always more solutions than you think that there are. And so many times on projects, especially younger, oh my gosh, this is horrible. I have no idea how we're going to, we have this deadline and we're not going to meet the deadline and this isn't going right. And I've been fortunate to have wiser, more experienced people say, okay, you're not going to meet the deadline. What deadline can you meet? Like, we can move a deadline. Yeah, you can move it. What? So now I know we can move a deadline. So now it's in my list of solutions to balance as we go forward. I remember having a project where I was doing process design. We were trying to put in this new line to make bread, and there was a big oven, and we were tearing out a bunch of equipment and putting in new, but some of it we were leaving in place. And so the oven was one that we wanted to leave in place because it was newer and it was expensive, and okay, we don't want to move the oven. But we were having a really hard time fitting everything into the physical layout with what we had left. So I remember telling my manager, man, it's really hard to fit all this in. And he said, well, what about the oven? And I said, well, we can't move the oven. He said, oh, yes, you can. It will be expensive, but that oven will move if you need it to. And it's all about your trade-offs. So there will become a point at which it is more desirable to move that oven than to try to do what you're trying to do with this thing. And that just blew my mind because I didn't even know that was an option. So he taught me that there's always an option on the table. It may not be a great one, but there is always another option for you to consider. So anyway.
Yeah, I think that's great. I mean, that's what I've loved about my training in engineering and my experience in engineering, is just that problem solving, troubleshooting, being solution oriented, and how important that is and how it just keeps you moving forward. It's something that it's probably the thing that I like the most about being an engineer and having that mindset.
Yes. there's very little that you can't do. There are some hard and fast lines. You cannot put people in danger. You cannot, there's some things, but
you cannot violate the laws of physics.
That's
the
right.
laws of
There are some hard and fast cannot do, but it is a much shorter list than you go into your career thinking that it is what I'm
Exactly. Definitely. So just a few more questions. So what do you hope your legacy will be?
I did a lot of thinking about this year because I did some leadership coaching, and she asked me, what do you want your 80th birthday to be like? It's like, I have no idea, but it got me thinking. I was like, I'll be retired by then. What do I want at my retirement party to look back on as like my set of accomplishments? I really want to be remembered as someone who helped others learn well, in ways that help them flourish. So the same leadership coach and I work together to develop, what am I uniquely positioned and created to do? Where am my personality, my skill set, all of that, where does that come together in something that I can uniquely bring to the world? And it ended up centering on that I kind of I enjoy absorbing lots of information. I read a ton, I learn a ton, like I'm just so curious. I like to absorb it and understand it, but then I really love to also share it back with others and teach them in a way that produces flourishing and joy. It doesn't always have to be things that I particularly know, even if I can help point someone to someone else who knows it or a book they should read. Like that is what I want to be known for, as someone who learned broadly, but then more importantly, used what I knew to bring others along and bring joy and flourishing. So yeah, that's what I'd love my legacy to be.
It's a great legacy. I actually got connected with you through your Substack called the Nightstorm Files. And so would you mind just telling us a little bit about the Nightstorm Files and what inspired you to get started with the Substack?
The Nightstorm Files is still somewhat of an experiment, to be honest, and I'm enjoying it and I'm learning as I go. I decided to start it because I was looking for something like it on the internet, and I could not find what I was looking for anywhere. So I thought, well, fine. I'll just just try it myself, because maybe there are other people out there that are like me who are looking for something like this and they can't find it. And if there's no one, that's fine too. I'll just enjoy writing it for my own sake. I enjoy, because I enjoy learning and I'm highly curious, and I am an engineer. And so I wanted something deeper than a newspaper article, but not a textbook. Mm-hmm. And occasionally I'll find podcasts that hit on that good sweet spot, or books that hit in that sweet spot, but they're hard to find. And I was like, I know they're out there. Who is recommending these? Where is the recommendation page for these types of books and podcasts? And I could not find it. You can Google, science podcasts, and they'll bring up a list, but what they won't tell you is which ones are at that level of depth and which ones are any good, because a lot of them are not as good as you think they are. Similarly with books, sometimes the books are not written very well. So I thought, okay, fine. I'll go explore on my own, and then I will write about what I'm finding, so that hopefully other people who are like me, who want to listen to these podcasts and find these books, but can't figure out where they are, perhaps I can start curating a list for some of them. So that's why I started it. I also enjoy sci-fi and fantasy, so I figured I might as well throw in recommendations for those while I'm at it. And then I enjoy just kind of board games and other superfluous things. So the Nightstorm Files is a recommendation where I recommend a podcast, a nonfiction science book, a sci-fi or fantasy book, and then something in a bonus category for people to explore and enjoy.
And how did you come up with the name?
Oh, Nightstorm. It's kind of my husband and I's team name for ourselves, and it kind of sounds cool, but my last name is Hale, and so if I had a nickname, which I really don't, but if I had one, it would be Hailstorm. And he, the longest time, has used video game titles as Nighthawk because he's an aerospace engineer. So we started playing escape room games together while we were dating, and whenever they would say, "What's your team name?" we would be like, Nightstorm, I guess, because that's like a squished hybrid of both of those. And it just kind of stuck. And so I'm not terribly creative, so the name coming up with names is really hard for me. So I had a name and I figured I'd go with it, and I kind of like it. So that's where the Nightstorm Files came from, is a combination of both of ours. He really doesn't have any input to the Nightstorm Files, so it's really not representative in that way, but it is a cool name that I enjoy using.
It is a cool name. And so do you have a favorite a book or a favorite podcast that you've recommended on your Nightstorm Files so far?
I have not recommended. If I had to come up with my favorite set of books, they would be really anything by Isaac Asimov. And I haven't recommended anything by Isaac Asimov because he's just so well known in the sci-fi fantasy world. He is one of my favorite authors to read. Other than that, I just, there's so many.
So this question was inspired by the podcast, The Diary of a CEO. And so what question would you like us to ask the next person that we interview?
The question I would love to ask someone is a question my friend actually asked, and I thought it was so good that I've now put it in my back of my head, is what is the hardest part of your job and how do you tackle it? As in, do you delegate it to someone else? Do you work on upskilling yourself in that area? Do you push it off until you can't handle it anymore? What's really difficult, and then how do you manage it?
Yeah, great question. Definitely. Do you have any recommendations for us about who we should speak to next?
Sure. You can. I had two that came to mind. I have no idea if either one of them will tell you yes, because I haven't told them I'm going to recommend them, but you can hit them up, see what happens. One of them is my older sister. She also has a doctorate in mechanical engineering, and she took a different path than me in that she is more in the entrepreneurial startup consulting world. She co-founded a company out of MIT, which is where she went to grad school, and then pivoted, and she now runs a small consulting business focusing on helping people translate concepts into first prototypes. So she would be really fascinating. She would have a similar background to me, but it would be interesting to see how she answers the questions differently. As she's kind of diverged somewhat. But you can also, there is a friend of mine who I think is currently in New Zealand. Her name is Dr. Ann Hulsey, and she is a civil engineer with a PhD, but she also has a focus in public policy. And so she likes to focus a lot on where is the intersection between things like building design and policies about it as it relates to natural disasters, and how do you make decisions about the right building codes, the right response to disaster and things. That's my explanation of what she does. She'll probably correct me as to what it actually is, but she's just a fascinating human being. She's really sharp, also loves to learn broadly, and she's doing a postdoc right now in New Zealand.
Oh, great. Thank you for those recommendations. They both sound fascinating. The work that they're doing also sounds fascinating. If you could write a book about a well-known person in science, technology, engineering, arts, mathematics, so STEAM, who would it be about?
I had a hard time. I was thinking about it this morning. I had a hard time coming up with one person. Honestly, the book I want to write, and may eventually write one day, I have no idea, is about the lesser known people in STEAM. So going back to that interaction in the manufacturing environment and how people use their bodies and their sensory cues to understand and run equipment, I think it'd be really fascinating to go do a book that's a series of interviews with people who are highly experienced in their craft at large scales. So there's books on people who are really good at like their small scale, creative craftsmen, whatever. Wonderful. I love those. But like, how do you know I go to plants all the time, and there are people who can tell when it's right just by how it feels and how it sounds. They've just gained so much experience in how the system runs that they're like, oh, it's not ready yet. They're like, it doesn't sound or it doesn't feel right. I would love to explore people who work in the STEM fields, but who have developed such a feel for things in ways that we don't usually express. And what that knowledge looks like and how it comes out. So that's the book I would write. I know it's not quite the answer to the question, but I would write it about the people who just who have developed a feel. And what does that look like? I think we watched Top Gun Maverick the other night, my husband and I. And so I thought about fighter pilots. You got to have a feel for it. It's not just all in your head. There's a feel for something. And how do you, anyway, that's what I heard.
Yeah, I think that in science, there are often places where it's a little bit more of an art than a science. We can't necessarily come up with a calculation or, some type of machinery or whatever that's going to do it. It's just a bit of intuition, a bit of serendipity, things like that. So, yeah, that'd be very fascinating to learn more about people who have such great experience, such a long, successful amount of experience in their field, to find out that play between the science and the art side of the whole process. So Yeah, that sounds great. I hope you do write it. So would you like to tell us, tell our audience where they can find you and learn more about your work?
Sure. The best two places, if you want to read all of my recommendations, I am on Substack at the Nightstorm Files, which we talked about. The other place that's the easiest to get in touch with me is on LinkedIn. I'm on there as Renee Hale, and you can find me. You can shoot a message if you just want to chat. I really love connecting with people and learning more about what they do. I never have a decent list of questions that I feel like are going to pop in some sort of introductory email, so I'm always shy about reaching out to people because it really feels more like, can we just like have coffee and I'll ask you a bunch of questions? Which I'm like, nobody in their right mind is going to say yes to that. I feel like I need to have something more than that to do with them to make it worth their time. But I have a feeling a lot of people are probably more like me, which is just, sure, I'd love to connect. Anyway, so LinkedIn and Substack are the two best places.
Well, thank you very much for making time to speak with me and our audience here at Origins. Thank you for enlightening us about the food industry and food engineering and learning more about what it takes to actually bring those foods to our markets. It's very fascinating and interesting. I'm thankful that you are my first chemical engineer on the program. As a fellow chemical engineer, I'm really excited to get people exposed to chemical engineering. So thank you for that.
Thank you.